So our situation is this. We have a cliff. We're dropping a rock off a cliff. And for the first, it takes 2 seconds to fall the first half. And then it takes, so we want to know how much time does it take to fall the second half. And so I sketched it out. And I always draw a sketch. I know you guys hate sketches, but I always draw a sketch and it helps me visualize it. So here's my rock, and this is V naught equals 0 right there, and then it's halfway. So if this is delta y all the way down, I'm going to call this delta y over 2 from there to there. And I know that the time here is equal to 2.0 seconds. And and then here, we'll call this T1, and then T2 is at the bottom. So really this is what's given. Now, on a multiple choice test, if you're having to get into given, find, and solve in a heavy way, skip the problem. Okay, I would probably skip this problem at first because it's taking me so much time. It took me so much time to get to the solution. But because your goal is not to get every question right. Your goal is to get as many points as possible in the time they give you. And the vast majority of people will not finish the AP Physics test in the time given. So you want to get as many points as possible. So anyway, what are we trying to find? We're really trying to find the time from here to here, which is really delta t, which is t2 minus t1. So let's solve this. Now, I've got this equation that, and let me zoom out a little bit. So, well, T1, I know. I need to find T2, and in order to, well, solve this thing. So, so here's how I did this. I said, well, I used the fact that I knew T1, so I used the third kinematic equation. Delta y equals V naught t plus 1/2 a t squared. Now, I got this from a multiple choice question. You can usually assume that the acceleration, instead of 9.8, you can call it 10, just to make the calculations easier. But anyway, V naught is 0, so this goes away. Now, so if we solve for t in general, we know that t is equal to the square root of 2 delta y over a. Right? Now, in this case, at t1, we have 2 seconds is equal to the square root of 2, but the delta y in this case is delta y, the total delta y, thank you, the total delta y over 2 over a. And so this 2 will cancel. I'll square both sides, and I get 4 seconds squared equals delta y over a. So delta y, the total delta y from here to here, must be equal to 4 seconds squared times acceleration, which I'm just going to call, say, 4 seconds squared. And I'm going to call this 10 meters per second squared. It's close enough. That's going to be 40, am I still, yeah, 40 meters. So now I can solve for T1. And because I know that this is 20 meters, right? Well, so T1, I'm sorry, I already know T1, I'm sorry, T2. So I know that this is 40 meters. So this is going to be 2 times delta y, which is 40 meters now, divided by 10. 2 times 40 divided by 10 is 8. So this is the square root of 8. So delta t is going to be equal to T2, which is the square root of 8. Minus 2 seconds, and so on my calculator, when I do that, I get 0.0 0.83 seconds, and that would be my answer. Okay. Now, my question to you is there a more elegant way of doing this? I think there is. You got one?
It's pretty similar to that, but I think it's
a little quicker?
It's pretty elegant.
Can I put it under here?
It's
I'm recording this too, by the way. This is going to be known to the world. Oh gosh. Okay, thank you. Here, let's take a look.
I guess maybe I should explain it. What?
Yeah. Okay. No, you go ahead.
Sorry. Should I just use a
Yeah, just put it right under there.
All right. I essentially split the problem into two parts, and the first part is you're looking for the distance crossed in the 2 seconds that we're given. The way you do that is you just set up.
Oh, you're not under the camera though.
Oh, it's this one.
You got to put this right over like that.
Okay.
And then you just kind of have to pay attention to the.
Right.
Oh wait, where's yours?
Right here.
Oh, okay.
Yeah.
Are you going to write on there then? Oh, okay. No, use that. I'm sorry.
Okay. All right.
I'll edit this video.
All right. So first part of the problem is we're calculating the distance that's crossed in those 2 seconds. The way that we do that where t is 2 seconds. Okay. So from here we can get. Let's see. It's going to be. Yeah. Well. Right.
Are you using the G right there? That's
gravity.
That's gravity.
Gravity. Yeah, gravity. Acceleration due to gravity. So we're done. That's the first part. The second part is to calculate the time associated with crossing twice that distance. We set it up this way. Okay?
I'm going to zoom in on that because I think
Yeah.
and you push the zoom in button, and then you move the. You'll get used to this. You move the camera. Where's your? Oh, I moved it.
Right there.
There we go.
Okay? Multiply each side out. You get. Right. We can take h right here and plug it into this equation, right? Is that, yes, okay, sweet. And so let's see, we have 4 1/2 g.
That is the most interesting G.
There are a few cancellations here, right? Well, we can get rid of the g. This is 2. 2 times 2 squared is 8. So what we have here is t, the square root of 8. And we simply take away the initial time of the first half to get the second half.
2 seconds.
Yeah. Right?
Very good. So there's a couple of ways to do that, and I am still. Yeah, we can. That is all.